All right, let's quickly run through the other functionality. So, as we said, on the controller, you've got physical buttons. So over here, up and down, and then power button. And then on this side, you've got OK and cancel. Okay, so again, we've got our red connected to the bottom here. If we had just finished a series of tests and we wanted to reset, we push the cancel button. That'll take us back to, this is like what I think of as the zero or the starting point. So it says reset. You'll see there also it's got our IP address. So if we click OK here, it'll reset all of our tests. Now, admittedly, it won't. The average will still be there, but it will, when you start going again, it'll be ready to go. So just quickly, if we clicked PT main, so you can see it's starting to test there. The LED is working, so when it picks up a test here, it'll go red. When it picks up a test there, it'll go blue, and if it's found both, it'll go purple, but it shouldn't be going purple here because there's nothing happening on this one. Now, just quickly, if we went up one, this would then look at this guy. So we can test away. So it's not finding anything here because it's nothing's happening. Okay, so that fits. We push cancel to stop that test. Again, if we push cancel again, takes us back to the reset screen, but that's not what we want. Now the next two, Mortal Kombat's not quite the game to demonstrate this. Screen time known. So we've told it that it's 120 Hz, 8.33 millisecond screen draw time. We've told it that this is 91% of the way down the screen. So when we run a test, it'll tell us, we're averaging 28 milliseconds here, which means that 90% of the way up the screen, it's averaging 20 milliseconds at the top. Now let's pretend we didn't know our screen draw time. So for example, this is a 240 Hertz screen, but it actually only draws at 120 Hertz when it gets a PS5 or it has a screen draw time of 8.33 milliseconds when it has a PS5 connected or an Xbox Series X connected, whereas when the PC's there, it can do the full 240 Hertz with 4.16 millisecond screen draw time. But if we didn't know that, what we could do is say this one's normally 25% of the way down, this one's 75% of the screen down. So you back calculate and you work out what the screen draw and what the hertz are. Okay, but like we said, because we've only got one here, that's not going to work. I don't know what that was. If we click here, then it will draw the graph of what's happening in real time. Okay. So for example, if you were getting dubious results, you could look here to see what's happening, and it might be often like sparks coming across the screen, or on the Tokon Beta, some of those cherry blossom leaves getting in the front was often causing disruptions, as then you might just need to move it to a spot where you're not getting those disruptions. Okay, and then also you can do this kind of thing. So this is basically displaying the results in real time so that we can see how it's kind of proceeding. Now the last one, compare 1p, 2p, that would be, for example, say, so you can use this to, although you'd probably be better off using the main board with the subboard connected. Say if you wanted to compare two controllers, you could have one photo transistor over the command history for player 1, one photo transistor over the command history for player 2, and then use the optically isolated pins here to trigger both controllers simultaneously. And so that would kind of be displayed here. So we'll just finish up. Done. Very quickly on the other side, so back to the reset, but we won't do that yet. If there were dubious results, you can set on your with your web page, you can choose to go back to a trial. So for example, I'll just take the jig down because I always struggle to read around it. So if we 28.32. It's a bit different to the last one. So for example, this all looks good. Let's say we had one all the way up here. We could either use that here to kind of choose the one that we want to repeat, or we can, always takes a bit of time for these to display, but I think I've talked long enough. You can go to test settings and just say if number test 32 was off, put test 32 there, and then just do one test. There is an option for only one test. There's an option to not save the data because it takes a bit of time and you might not need it. Thought that had been updated, but apparently not. This might actually, I might not have uploaded to this board. Yeah. What else? So if you keep going further, it'll give you basically what we put here. So this is formatted to ready to copy and paste into our spreadsheet. And if people share those with me, I would be ecstatic. You can, with your serial connection, you can print out all of the tests. So say if you missed one on the way through, you can go back and get them. Delete all, because all of this is taking up memory on the little the Pico 2W's 4 megabytes of file system. So eventually it'll run out of space. Review, I don't think we do there. Print summary, forgotten. This is just internal, used for timing, where I can put 2 markers within my code and make sure that we're not exceeding our 100 millisecond cap, because we're trying to hit 10,000 hertz testing. And then a couple of empty ones, and then we've got temperature on the Pico 2W. So that's the temperature of the chip, obviously not the temperature of the room because we're in winter, but you can use that. So just to finish, again, 5, Legacy Collection, Ultimate Mortal Kombat 3 patched. And like we said, we can save that. And if you wanted to go back and compare some old results, just open them up and then maybe show that Mortal Kombat's had a massive reduction in its input lag from its release date, which I do think I don't think they get their kudos. I've said it before. I think people are too quick to come in negative when things are not good, and there is not the same in the opposite direction when the team has made a massive effort to get it all the way down. Anyway, that is pretty much that.